So when we think about our digestive system, it's easy to just picture a simple tube that food passes through. But it's so much more than that. It's actually this incredibly complex, beautifully choreographed performance, a kind of dance that's happening inside you 24/7 without you ever having to think about it. So today, let's pull back the curtain on that incredible show.
We have all been there, right? You finish a meal and pretty soon the gurgling and the rumbling starts. But have you ever really stopped to think about what's going on down there? I mean, who or what is directing all of that traffic? It's definitely not just gravity pulling things down. It is a super sophisticated system of movement, a secret rhythm that our bodies have absolutely perfected over time.
Okay, so at the very heart of this entire performance are two fundamental dance moves that the gut uses to process literally everything we eat. You can think of them as the basic steps, right? The foundation for all the more complex routines. One move is all about pushing things forward, and the other is all about mixing things up. And these two moves, they have very different jobs. First up, you've got peristalsis. This is the propulsion wave. Basically, when the gut wall stretches from food, it triggers this wave of contraction that just pushes the food forward, always in one direction, downstream. Then you have segmentation, which is like the mixing churn. This is a series of back and forth contractions that, brilliantly, actually slows things down. It makes sure all the food gets thoroughly mixed with digestive juices so we can absorb all the good stuff. So one pushes, the other mixes, and you absolutely need both for this to work. Now, here's what's just fascinating about all this: how self-sufficient the gut is. Peristalsis is what's called an intrinsic property. That means it's run by the gut's own onboard computer, the enteric nervous system. It doesn't need the brain to tell it what to do. It's a localized automatic reflex. It's pretty amazing. So, if the gut has its own nervous system and can move on its own, what's setting the tempo? How does it coordinate everything so perfectly? Well, this brings us to the unseen conductor of the entire orchestra, a secret electrical system that dictates the pace of the gut's entire choreography. It's called the basic electrical rhythm, or BER, and you can think of it just like the heart's pacemaker, but for your gut. There are these specialized cells, they're called the interstitial cells of Cajal, that generate these slow, rhythmic electrical waves. Now, these waves don't always cause a contraction by themselves, but they set the rhythm. Contractions can only happen at the peak of the wave. This is the master beat that keeps the entire system in sync. And this rhythm isn't just one boring, monotonous beat. Oh no, the pace changes dramatically depending on where you are in the gut. In the stomach, it's a slow, steady, powerful grind at about 4 cycles per minute. But as soon as that food hits the beginning of the small intestine, the tempo just skyrockets to 12 cycles per minute for some really intense mixing. Then it slows way down again in the colon. Each part of the tract has the perfect beat for its specific job. Okay, so now that we know the basic moves and the rhythm that drives them, let's take a quick tour through the digestive tract and see the full performance in action, from top to bottom. First stop, the stomach. You know, its first job isn't to contract. It's actually to relax and expand, to make room for the food you just eat. That's called receptive relaxation. Then, guided by that slow BER of about 3 to 4 waves per minute, it begins these powerful peristaltic contractions. It's not just pushing, it's mixing, grinding, and churning your food into this liquid called chyme, which it then releases into the small intestine at a very careful, controlled rate. And how fast that happens? Well, it depends entirely on what you ate. You've probably felt this. Carbohydrates, they move through the stomach pretty quickly. Proteins take a little longer. And fats? Well, fats slow that process way down, which is exactly why a fatty meal can leave you feeling full for a lot longer. Next, we head into the small intestine, which is really the main stage for digestion and absorption. The pace here just explodes, with the BER hitting its peak of up to 12 cycles per minute. This fast rhythm is what drives all those segmentation contractions we talked about, constantly churning and mixing the chyme to make sure every last bit of nutrient can make contact with the intestinal wall and get absorbed into your body. Finally, we get to the colon. Its job is completely different. Think of it more like a reservoir. Here, motility slows right down. The goal isn't rapid mixing anymore. It's about giving the body time to absorb water and minerals. And it is incredibly efficient, turning over a liter of liquid into just about 250 milliliters of semi-solid feces. Then, a few times a day, it triggers these mass action contractions, these big, powerful squeezes to move everything along towards the exit. But the gut's performance isn't just about digesting your meals. It also runs a super tight ship. It's got special operations for housekeeping and even a full-blown emergency protocol for when something needs to get out fast. So between meals, when your gut is empty, it's not just sitting around doing nothing. It kicks off something called the migrating motor complex, or MMC. And this is literally the gut's housekeeping crew. It's this powerful wave of contractions that sweeps all the way from the stomach through the small intestine, clearing out leftover debris, bacteria, any residue, just to get the place clean and ready for the next meal. You know that rumbling you hear when you're really hungry? That's often the MMC at work. And this isn't random. The MMC runs on a really predictable cycle, repeating about every 100 minutes or so when you're fasting. It starts with a quiet phase, then moves into some irregular contractions, and finally culminates in this short but really intense burst of activity that pushes everything through. This whole cleaning cycle is kicked off by a hormone called motilin, and as soon as you eat, motilin is suppressed. It's like telling the housekeeping crew, okay, break's over, back to digestion. All right, now for the emergency protocol, vomiting. I know, it feels chaotic and awful, but it is anything but random. It's actually a highly coordinated, centrally regulated protective reflex. Its whole job is to get a potentially harmful substance out of your system as quickly and efficiently as possible. The whole process is remarkably precise. It actually starts with a reverse peristalsis, pulling stuff from your small intestine back into the stomach. Instantly, your airway seals off to protect your lungs. Then, your abs contract powerfully, squeezing the stomach just as your esophagus relaxes. And, well, you know the rest. It's this complex sequence, all perfectly orchestrated by a vomiting center in your brainstem. So, when you put it all together, from the rhythmic waves of the BLER to the distinct dance moves of peristalsis and segmentation, and even these specialized routines for cleaning and for emergencies, the gut's choreography is just an astonishingly complex and elegant performance. It runs nonstop, perfectly adapting its rhythm and its movements to whatever the task is, all without us having to think about it for a single second. Which, brings us to a final thought. This whole intricate system evolved over millennia. It has a natural, ancient rhythm. So the real question is, how does our modern lifestyle, our diets, our stress levels, our weird eating schedules, how does all that either support or disrupt this incredible internal choreography? It's definitely something to think about.